VPN all the things is what VPN providers tell you. But in reality, not all traffic should go through a VPN. To navigate this, you could do something called split tunneling. Let me show you. Welcome back to Dev Odyssey, a developer's journey through IT, where I cover tutorials and reviews of IT tools and technologies. I'm your host, Orest, and in this episode, we're covering split tunneling and policy-based routing. First off, what exactly is split tunneling? It's a technique used in networking for forwarding and routing packets according to pre-written policies or filters. Split tunneling is also referred to as policy-based routing, and in my research, I couldn't find many differences between the two, except for a couple. VPN providers tend to use the term split tunneling and offer VPN desktop applications capable of split tunneling. These apps can split tunnel traffic per desktop application, like Chrome, Microsoft Office apps, and more, while policy-based routing does not route traffic per desktop application and is usually terminology for networking equipment like routers and firewalls. Generally speaking, split tunneling is usually associated with only VPN interfaces. Policy-based routing allows you to create routing policies based on port, IP, domain, MAC address, and protocol for sending traffic through your interface of choice. This term is usually associated with any Layer 3 interface, including VPN interfaces. Regardless of the terminology used, they both accomplish similar goals. With that in mind, what could those goals be? For starters, it enables you to access geo-block content by routing domains or websites of your choice through a VPN interface. In the same regard, you can route websites that don't need to go through a VPN for reasons of preserving VPN bandwidth, preserving access to your local network, and more. Not all traffic should go through a VPN, and with split tunneling or policy-based routing, you're able to achieve that. For this demonstration, I'll be using my Raspberry Pi hotspot I recently made. If you missed that video, go check it out in the card above me. For software, I'll be using OpenWrt 22.03 and the packages PBR and Lucy App PBR. Just to note, the PBR package has undergone some changes since the prior release of OpenWrt 21.02. Before 22.03, PBR used IP tables to create policies. 22.03 and beyond, it uses NF tables. There are some differences between these backends. However, from a front-end standpoint of the PBR app, you shouldn't see a significant difference. For more information, refer to the link in the description below. For my interfaces, I'll be using a WAN interface and two VPN interfaces, Wireguard and OpenVPN. For more information on setting up a Wireguard interface, feel free to watch my video in the card above me. As for OpenVPN, there are plenty of videos covering that. However, if you want to follow along, you can refer to the article below from Mulvad, where they cover OpenVPN on OpenWrt. If you'd like to see me cover OpenVPN, drop me a comment below. Now that we've covered the prerequisites and learned about split tunneling and policy-based routing, let's look at how it's done. To get started, we'll download PBR and Lucy App PBR under System and Software. With these packages installed, let's look at the interfaces we'll be using. As you can see, we have a WAN interface, a WireGuard interface named WG, and an OpenVPN interface named OVPN. These interfaces are both being tunneled to different IPs, so we can verify that our policies are working. At the Services tab, we'll find Policy Routing, where we will review the options. At the top, you'll see a few things under the Status section: the Service Status, Service Gateways, and Service Control. Service Status simply tells you what you expect, if it's running, and if it's stopped. Service Gateways show you the interfaces you are connected to, their IP addresses, and which is the default gateway. In my setup, I have WAN as the default gateway. And in order to do that, I had to specify certain configurations within WireGuard and OpenVPN interfaces. You can find what those are in the links in the description. I chose WAN as it means I can do policy routing for all interfaces. If the WireGuard interface was my default gateway, I could not do policy routing due to limitations of the service. With OpenVPN, there is no limitation. Your default gateway will depend on your use case. Lastly, with service control, you can start, restart, and stop the service, or enable and disable it for automatic start on boot. Moving on to the configuration section, under Basic Configuration, we have a few general settings that I'd recommend you leave as default. Output verbosity is how detailed you want your logging. Strict enforcement ensures policies always work, regardless if the gateway associated with the policy is down, meaning the traffic destined for a down interface will drop. You can set it so it does not operate this way, and traffic will follow the default route instead of being dropped. Use resolver set support for domains allows you to use a cache of DNS resolutions for domains. This improves the speed of the service, but needs to be specifically set up. For this video, I have not done that, so the only option is disabled. IPv6 support is as it sounds, and as I do not utilize IPv6, I leave it as disabled. Under Advanced Configuration tab, I leave these all as default, and I'll highlight Select Settings. Supported interfaces allows you to explicitly specify which interfaces you want to use with this service. It's not necessary, as all interfaces will be automatically available, but a potentially useful option. Ignored interfaces is the opposite. This is mostly useful for interfaces that are destined as server interfaces, ones you use to connect to your home router from the outside network. So server VPN interfaces for WireGuard or OpenVPN would be ones to specify here, as you see in their example. As for the rest of the settings, they are straightforward, and you can refer to the documentation for more information. For Web UI configuration, this simply shows additional Web UI options. For Add Ignore Target, this is useful for writing policies that you want disregarded by the service. This is typically done with local traffic. This depends on your default gateway, but this option can be useful. Supported protocols allows you to specify more protocols than what is listed. You can find the full list under Etsy Protocols. We'll skip the policy section, as that is where we'll demonstrate policy creation after I touch on the last two sections. In DSCP tagging section, this means Differentiated Services Code Point. This is used for identifying latency-sensitive traffic for means of prioritization during network congestion to improve quality of service. For anyone who uses DSCP tags, you can create policies based on these tags to route DSCP tag traffic through a specific interface. The purpose of Custom User File Include section is to define the location of scripts used to populate IPset or NFset with domain-to-IP mappings. In particular, this is used for streaming domains like Netflix, AWS, and Hulu. This enables the service to use the resolver sets so that it doesn't have to use DNS to look up the IPs. Otherwise, if your default gateway is a VPN interface, and DNS requests are being made over the VPN interface provider for streaming services, you might lose access to your streaming services, as they actively prevent VPN usage of their services. If your default gateway is your WAN interface, then you can ignore this. If you have any questions on accessing geo-based content, drop me a comment below. For more information on this section, refer to the links in the description. Now that we've covered all these sections, Let's create a couple of example policies using domains. Revisiting the policy section, we see a few default policies set. They are not enabled, but they are there as examples for us. For now, we'll ignore these, and we'll begin by creating our first policy. Click the Add button at the bottom left hand of the table. Let's go over each field. The first is a checkbox for enabled. Bear in mind, if this is not checked, the policy is not enabled. It's easy to miss, as you just think because it's in the table that it's enabled, but that's not the case. Next, we have name. So choose something descriptive that makes sense. For me, I'll call this IPinfo WG test. Then, we have the possible fields we can use for policy routing. First, we have local addresses or devices. Here, we can put IP addresses, subnets, host names, and even MAC addresses. For my demo, I will leave this blank, which means all local IPs. But if you want certain devices to only follow this policy, this is where you put their network information. Following, we have local ports. This is where you put the local port or range of local ports you want in the policy. This is the port that the connection is initiated out of for the device. Since ports are often chosen at random for client devices when initiating a connection, it doesn't make sense to specify this field. However, if you have a scenario where a local port will constantly be used for a connection, and you want a policy around it, this is where you would do that. Again, I'm leaving this as blank. For remote addresses domains, this field is one you'd use often. Simply put the destination you want your devices to reach over your interface of choice. This can be a website name, a domain name, or an IP address. For my example policy, I will put the domain ipinfo.io. For remote ports, the same logic applies as the local ports, except this is a field that you'd use more often. If you want only web traffic in this policy, then you can use ports 443 and 80. In my example, I'll use 443. Just to note, some web traffic may use non-standard ports, so keep that in mind when writing your policies. For protocol, simply put the protocol you want to be affected by this policy. Since I'm making this policy for web traffic, or HTTP, I will choose the TCP protocol. For chain, this refers to Linux networking concepts on how traffic is handled at different stages. I won't get into the detailed explanation here on what chains means, but I'll leave the link in the description below for more information. For my example policy, we'll follow the examples they have and use the pre-routing chain, which is what you will want most often. Last but not least, we get to the interface section. This is where we choose what interface this traffic leaves from. Since this policy is to test Wireguard, I will choose the WG interface available. With our choice policy options set, click Save to create the policy. Next, let's make another policy. It will basically be a duplicate of the one we just created, except this time, we'll be using the OpenVPN interface. Click Add to create the new policy. Let's call this one ifconfig OpenVPN test. Leave local addresses and local ports blank. In remote addresses domains, type ifconfig.me. For remote ports, type 443. For protocol, select TCP. For chain, select pre-routing. Lastly, for interface, choose OpenVPN interface, OVPN. Now that we have these two policies set up, we'll test them out, along with verifying the default gateway. The best way we'll test this is by using the terminal to visit websites in the policies we created. That will show us are public IP of the interface that traffic is routed through. First, let's test our default gateway, which is the WAN interface. We'll jump over to the terminal and run curl http://ip-api.com. This is my IP address from my ISP, so the default gateway is clearly working. To test out the first policy through Wireguard interface, we'll run curl ipinfo.io in the terminal. This IP is clearly different than the first IP and closely matches the endpoint IP of the Wireguard peer. So it looks like this policy is working as expected. Lastly, let's test the last policy, routing through the OpenVPN interface, by running curl ifconfig.me. As expected, this IP is different from the last two we saw. This IP may change because of the OpenVPN settings in my config file, but they should be close to each other. Regardless, we can confirm that the last policy we wrote is working as expected. And that covers our quick demo on split tunneling and policy-based routing. As you witnessed, split tunneling and policy-based routing are very powerful tools in a network admin's arsenal. With the ability to decide what traffic should leave what interface, you can customize your network to suit your bandwidth, media, and privacy needs. The criteria for which you can create policies allows for flexibility in choosing the right traffic for the right interface. For anyone who utilizes a VPN on their router, I'd strongly recommend they use policy-based routing to ensure they get the best network performance and user experience as possible. Thanks for following me in my journey. I really appreciate it. If you got some value out of this video, go ahead and give it a thumbs up. And if you like this type of content and other content around IT technologies, networking, security, and more, go ahead and subscribe to my channel and click that bell for notifications so you don't miss the next video. Want to learn about other VPN technologies like OpenVPN or IPsec? Drop me a comment below and we'll discuss it. Thanks again, and I'll see you in the next video.